Today we're going to look at exponential and logarithmic inverses a little bit closer, and we're also going to solve them in equations. So recall that exponential functions and logarithms are inverse functions. We looked at that in our last couple of lessons. Now we're actually going to find those inverses. So number one, find the inverse of each function below. Number one, f of x equals the quantity of the square root of x over 7 to the fifth power. So let's find the inverse. So we're going to switch our x and y. F of x means the same thing as y. So I'm going to switch my letters here. X equals, I've got the square root of y divided by 7 raised to the fifth power. And now let's solve for y. Now I've got the square root of y divided by 7 all raised to the fifth power. Let's get rid of that fifth exponent piece first. So you can undo the exponent by doing the square root. Well, sorry, you can do the fifth root on both sides here. So we would have the fifth root of x is equal to, I just have that square root of y over 7. The fifth root and the 5 exponent cancel out. I don't really need the parentheses around my square root of y over 7 anymore, and you can start to see now we need to get rid of that division of 7. So multiply both sides by 7. So on the left side we have 7 times the fifth root of x equals the square root of y. Kind of like we did a moment ago, undo the square root of y by squaring both sides. And then we would just have y. So we have 7, the fifth root of x, all squared equals y. That's my final answer. Let me just write it in inverse function notation. F inverse of x equals 7, the quantity of 7 times the fifth root of x all squared. 7 times the fifth root of x squared is our inverse function. Number two, f of x equals 3 raised to the, we have x plus 7 divided by 9, all as our exponent. So this one is a little bit different because now the variable that I'm looking for is up there in my exponent. So we're going to utilize the properties of logarithms to rewrite this. Let's first start by changing it so we can solve for our inverse. Let's change it to x equals 3 raised to the y plus 7 over 9. And recall, we're trying to solve for y to find our inverse. Again, that variable is up in the exponent. So let's change this to a logarithm. Logarithm of base 3 of my answer, x equals the exponent piece, y plus 7 over 9. At least now my variable is not in the exponent. I can start to solve. So we're trying to solve for y. Let's multiply both sides by 9 to stop that division there. So we have 9 times logarithm base 3 of x equals y plus 7. Deep breath. You see it now? Much simpler. Subtract 7 from both sides, so we'd have 9 log base 3x minus 7 equals y, and I am done. I'm just going to write it in that inverse notation, inverse function notation. F inverse of x equals 9 times log base 3 of x minus 7. Final answer. All right, number 3, f of x equals e raised to the x raised to the 1/4. We got an exponent raised to an exponent, power to power there. Let's change this so we can begin to solve for our inverse. Switch our letters. X equals e raised to the y raised to the 1/4. All right, let's start with that 1/4 exponent. That is the same as a fourth root. So if you want to change that into a fourth root, and that helps you solve. Remember, a rational exponent is the same as a radical. You can do that. In either case, we are going to raise it to the fourth power on both sides. So whichever notation you prefer, I'm going to use the same inverse operation to cancel it out. So raising it to a 4 power on both sides. So we have x to the 4th equals e to the y in either scenario. Now recall, again, my issue is that the y is the exponent. So we're going to use the logarithm functions to rewrite this. I've got the logarithm base e. If you have base e logarithm, that's a natural log, ln base e. of my answer, x to the fourth, equals my exponent. Now, everyone knows a natural log does have a base e, so I could just write this as natural log of x to the fourth equals y, and I'm done. You see that? My y is isolated. So final answer, f inverse of x equals the natural log of x to the fourth. Seems too simple, right? Number 4, f of x equals 8 times the quantity of e raised to the fifth root of x, and then back down on the base floor there, minus 2. So the minus 2 is not in my exponent there. Obviously, let's switch our letters first. X equals 8 times e raised to the fifth root of y minus 2. Everything is getting multiplied with 8, so let's divide both sides by 8. X over 8 equals e raised to the fifth root of y minus 2. Again, the minus 2 is not in the exponent there, so let's add that to the other side. We have x over 8 plus 2 equals e raised to the fifth root of y. So again, my issue is the variable is in the exponent, so we're going to use the properties of logarithms to rewrite this. I'm going to have a logarithm of base e, which we just recalled in the last problem. A logarithm base e is natural logarithm, so we have ln, you can put the base e, but it's not necessary, of x over 8 plus 2 is equal to the exponent, the fifth root of y. You can undo that fifth root by raising it to the fifth power on both sides, and we'll be done. Let me write it for you one more time here. We have the natural log of x over 8 plus 2, all raised to the fifth power, is equal to y, is my final answer, because I canceled out the fifth root by raising both sides to the fifth power. Let me write it in inverse notation. F inverse of x equals natural log, let me use big brackets here, natural log of the x over 8 plus 2, all raised to the fifth power. Final answer, big and messy there, but it really did apply everything that we've kind of built up to. Isolating, using logarithms to rewrite. This was a base e, so a natural logarithm, and then we used an exponent to undo the root there. In this next section, we're going to get a little bit deeper into exponential functions and logarithmic functions being inverses, referring to their graphs, and also talking about their asymptotes and their range and domain. Number 5, as an example, the function f of x equals 3 raised to the x plus 5 minus 8 is graphed below. Plot the points of the inverse and then use the labeled points as your guide. And then we're going to go over to the right here. We're going to find the inverse function, identify the asymptote, and as I said, domain, range, and increasing or decreasing. So let's start with the fact that this is an exponential function. X is my exponent here. So our inverse is going to be a logarithm. Let's start by plotting our inverse. So let's just use the points that they gave us. So we had over here this -3, 1. My inverse, the x and y get switched, right? So we're just going to plot +1, -3. Over here, we have -4, -5. So I'm going to have -5, -4 on my inverse. And then this provided plot is -5, -7. So let's have -7, -5. Once you plot these, Delta Math will connect the dots for you. So let me try my best here to connect these and hopefully show you the correct features of our inverse logarithmic graph there. So to the right, we're going to find our inverse. So I'm going to go ahead and copy our problem here. F of x equals the given function is 3 raised to the x plus 5 minus 8. I'm going to switch my letters here. So we'll have x equals 3 raised to the y plus 5 minus 8. Solving for the y to find the inverse, add 8 to both sides. We have x plus 8 equals 3 raised to the y plus 5. My variable is in my exponent, so use the rules of logarithms to rewrite this as log the base is 3 of x plus 8 equals the exponent y plus 5, and you're almost home free. Y is almost isolated. Just subtract 5 from both sides, and we'll have it there. Log base 3 of x plus 8 minus 5. Notice I use those parentheses to help illustrate what is part of the logarithm, and then the subtraction at the end of minus 5 equals 8. So there's my my inverse. I'm going to put it in our blank over here, log base 3 of x plus 8 minus 5. It has a vertical asymptote. Recall from your notes, your logarithms have a vertical asymptote. This one is going to be x equals -8. We use x to identify that vertical line. It is at -8, which is also indicated as your h value here, will also be your asymptote. The range of our function, our y values, how low does it go? How high does it go? Remember, in logarithms, this is going to be all real numbers, so -infinity to +infinity. I've tried my best to graph it here. You can see left arrow is going down, down, down. Right arrow is ever so slightly creeping up. It is, as I look at the graph from left to right, it is increasing from left to right, and on the domain of from, now remember that asymptote is at -8. So the purple logarithmic graph that I drew, it is getting closer and closer to -8, but will never go further than that. It's not going to go to -9, -10. It's bumped up and can't go past -8, and then it's going to shoot over to the right forever to infinity. We're going to do the same thing with number 6. The function provided, however, is f of x equals the logarithm log base 2 of x plus 3 plus 2 is graphed below. Plot the points of our inverse and use those labeled points as your guide. Let's go ahead and do that. Again, let's show this is obviously a logarithm. Our inverse is going to be exponential function. They gave us -2, 2, so I'm going to have +2, -2 in my inverse. They gave us -1, 3, so I'm going to have 3, -1. They gave us 1, 4, so I'm going to have 4, 1. And they gave us 5, 5, so I'm actually going to be there as well. 5, 5 inverse, switch your x and y, you still have 5, 5. So again, Delta Math will draw this for you. I'm going to try my best to make this look beautiful and accurate for our features, but there would be my exponential function. Let's fill in our blanks over here. We got to find our inverse. So the given inverse was f of x equals log base 2 of x plus 3 plus 2. When I switch my letters here, we have x equals log base 2 of y plus 3 plus 2. Trying to solve for the y, it's in the parentheses of the logarithm. Let's take care of the plus 2 with inverse operations. Subtract 2 from both sides. X minus 2 equals log base 2 of y plus 3. It is time to use the properties of logarithms and exponential functions, and let's rewrite this because the piece that I need is stuck inside that logarithm. So I would have my base 2 raised to my answer, x minus 2, equals my logarithm, y plus 3. Ha! Now that y variable is free. It's not trapped in that logarithm anymore, and we can easily isolate it by subtracting 3 on both sides. So we have 2 raised to the x minus 2 minus 3 equals y, and I'm home free. So our inverse is exactly that. 2 raised to the x minus 2 minus 3 is our inverse function. It has a horizontal asymptote. Recall exponential functions have a horizontal asymptote. I've already dashed that down over here. Horizontal asymptotes, we write that horizontal line as y equals, it is approaching -3. You can also see that in your exponential function. It's always going to be your k value is your asymptote in exponential functions. So y equals -3 does match our inverse function up there. The range, how low does it go to how high? Remember, range is our y values. How low does it go? It is hitting that asymptote as it goes down. It's not going to go any lower than -3. So we're stopping at -3 and going up, up, up to infinity. It is increasing from left to right as I look at that purple graph. And the domain, x values, how far left does it go? All the way out to -infinity. How far right does it go? It's going to keep creeping out, okay? So I tried my best to graph that purple there, but it is going to keep creeping out exponential functions, the domain is all real numbers. So check your notes back there from our last couple of lessons if you need a refresh. And the last part of our notes here, rewriting those expressions using logarithms can help you solve many types of problems. So we're going to get a little bit deeper into using inverse operations of logarithms and exponents to solve equations. So solve for x and round to the nearest hundredth. Number 7, we have 3 raised to the x equals 37. My x is stuck in my exponent. And so that's what the big idea behind logarithms is that it helps me get that variable out of exponent land. And so let's rewrite this as log base 3 of 37 equals x. Now I have everything on the left side that I need in order to come up with a value that x would be equal to. So let's grab our calculator and we can find out what the log base 3 of 37 is, and we'll round it to the nearest hundredth. All right, so grabbing our calculator, we have our control, your log button is there, and then we have 3 of 37 and enter. We have x equals 3.2867999, just writing a bunch here. So you can see those if you can't. On my calculator, rounding to the nearest hundredth is 2 decimal places. The 6 tells us how to round. We are going to raise it up. 6 is more. So 3.29 would be our final answer for number 7. Number 8, 550 times 2 raised to the x equals 55. Go ahead and isolate where your variable is. So divide both sides by the 550 here, and you can have 2 raised to the x equals, this is going to be 1/10, or you could write it as 0.1, like as a decimal 1/10 there. And then we will use logarithms to help get that variable out of our exponent. So log base 2 of the 1/10 would equal the exponent x. And again, we can use our calculator to help us figure out this value that is equal to x. Let's grab that calculator. Control log base 2 of the 1/10 there is equal to, again, writing it. So if you can't see it on my calculator, negative 3.321928 on and on. Again, rounding to the nearest hundredth is 2 decimal places. The 1 tells us how to round. We are to let it rest. So the negative 3 and 32 hundredths is our final answer for number 8. We're still doing the same thing on this last section here. We're still solving for x. We're still rounding to the nearest hundredth. Just things get a little bit more complicated. You are welcome to use the same process we were just using on 7 and 8 to solve by hand, but I want to reveal to you a very helpful tool on your calculator, and I think this might be the first time I've ever shown you this function on the Inspire. You can see those calculator steps to the right. These problems are going to be so super easy. We're going to grab the calculator. We're going to float through these really quickly. So let me do that. Let's just walk through the calculator steps. Using number 1, so on our calculator page, I'm good where I'm at. I'm going to go to Menu, Algebra, Numerical Solve. So let me go ahead and tell you what Numerical Solve can do for you. And this is really helpful for ACT as well, even more simple equations. So Numerical Solve will solve any equation, so it has to have an equal sign, any equation in one variable. So it can only have x. Can't have x and y. So any equation, one variable, will solve it for you. You have an equation solving tool on your Inspire, and so this is where we are shocked when we're allowed to use this calculator on your end of course test or on ACT. We're like, really? So let's do that. We did Menu, Algebra, Numerical Solve. Go ahead and open that up. You're going to see that in solve. You'll hear maybe classmates or friends or other teachers talk about in solve. You might hear me refer to it as in solve because that's how it populates on our screen here. Now the rules are you have to type the entire equation. You can see this here on your calculator notes. Type the entire equation the way you see it. Every part, left side, equal sign, right side, the entire equation. Then you have to do a comma and tell the calculator the variable that you're solving for. Calculator's super smart, but this is where it kind of is faulty. It needs help. All right, so we're going to do number 1 here. We're going to do 10 raised to the x. Now, careful on these. Arrow out. arrow to the right here. We were up in the exponent land. I need to come back down to the floor. So we had 10 raised to the x, arrow over to get out of the exponent land. Your equal sign is right here below the control button, 93. There's my full equation. 10 raised to the x equals 93. Double check. Make sure you get your equals 93 out of the exponent. All we did was just arrow over. Now, last part. Don't forget, comma, x. You got to tell it what letter it's solving for. And enter. Done. X equals 1.968. We're rounding to the nearest hundredth, 96. The 8 says rounded up, so 97. 1.97 or 1 and 97 hundredths. Number 2, let's go ahead and dive in. It's going to do menu, algebra, numerical solve. I'm typing in 51. Your E is right below, beside your log buttons there. E raised to the x, arrow out of exponent land, equals 510, comma, don't forget comma, 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 and our variable is x. Now enter. All right, x equals, final answer, 2.30. The 2 in the thousandths place says let it rest, so we're good. 2.30 or 2 and 30 hundredths. Number 3, let's keep going. Menu, algebra, numerical solve. 10 raised to the 3x, arrow over to get out of the exponent part, equals 98. Don't forget, comma, x. Now enter. X equals 0.66. The 3 says let it rest. So 66 hundredths, final answer for number 3. Ready? Here we go. Number 4, menu, algebra, numerical solve. 8 times, I'm going to use the multiplication key there. 8 times 10 raised to the 3 to the x, arrow out of exponent land, equals 1. Don't forget, comma, x, and enter now. I'm going to make a song. X equals negative 0.30. The 1 said let it rest. So negative 30 hundredths there. We're ready for number 5. Menu, algebra, numerical solve. We had 1.7 equals 3 raised to the, this is a lot. All right, so this is where I love the Inspire, that it has the fraction boxes. So I'm going to do control divide to give me those numerator and denominator boxes there so I can clearly see what I'm working with. We have x over 10 in the fraction, arrow over, so I'm out of the fraction but still in the exponent, plus 4, arrow, so I get on the floor, minus 3. So I chose this problem because it is wild and crazy, and typing it in our calculator takes some skill. So check this out. Don't forget, comma, x, and now enter. Hopefully you got the same thing I did, negative 25.91, and we let it rest there. Negative 25 and 91 hundredths. Last one here. Notice on number 6, there are exponents on both sides. You can still use logarithms. You've got to come up with common bases. Delta Math will definitely show you the solving process if you want to do that, but we get to use our calculators on our end of course. So here we go. Menu, algebra, numerical solve. We have 16 raised to the x plus 1. Arrow out of the exponent so we can do equals. 256 raised to the x minus 1. So we're asking ourselves, what would the x have to be? And the x would have to be the same number in the exponent, so both of these sides are equal to the same number. Don't forget to arrow over to get out of the exponent, comma, x, then enter, 3. The exponent on the left and the right would have to be 3, so that we have 3 plus 1 on the left, 3 minus 1 on the right. And with those different bases, it all works out and both sides would be balanced and equal. Kind of crazy, but the solving by hand part's kind of cool. All right, so we covered a lot. We really dove in a lot deeper into the fact that exponential functions and logarithmic functions are truly inverses. We literally solved for the inverses in the first part. And then 5 and 6, we looked deeper into the functions, graphing them and looking at the different vertical and horizontal asymptotes, how the domain and range are different there. I really like that practice on Delta Math. it's really deep into that math and really solidifies all the lessons that we've been working on here. And then lastly, that we can use them as inverse operations to solve equations, and revealing to you that you do have that numerical solve feature on your calculator that solves any equation in one variable. So even if you wanted to solve a linear equation or something, from algebra 1, that is possible. We've just got up to the point here where you can use it, and I'm okay with you using it for these exponential equations. So let me know if you have questions, guys. Good luck. Have a great day, and I'll see you in class.